Set up an integral for finding the area of the region that is bounded by the graphs of r1 equals 1 plus cosine theta and r2 equals 3 cosine theta. In order to find the area, remember the area is 1/2 the integral between our limits of integration of r squared d theta. So to go any further on this, we need to find two things. Identify the r and identify the limits of integration. To do this, it's handy to have a sketch. So what we'll do first is sketch these two graphs in rectangular and then convert over to polar. So here's our theta axis, our r axis. The first curve is r equals 1 plus cosine theta. This is a cosine graph that's been shifted up 1 unit. So cosine graph is going to start at the peak, which in this case is 2. It'll dip down where it'll zero out halfway through, and then back up to the maximum at theta equals 2 pi. Halfway between 0 and 2 pi is pi. Halfway again would be at pi over 2. Halfway between pi and 2 pi is 3 pi over 2. So if we sketch this out in polar, we've got theta equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if we start out at theta equals 0, our r value is 2. So looking in the theta equals 0 direction, we're going to go 2 units out. That's going to be our first point. Now, as r increases, as theta increases from 0 to pi over 2, the r value is going to steadily decrease until it gets to r equals 1. So as theta sweeps out in this direction from 0 to pi over 2, the r value is going to decrease from 2 to 1. So we're going to sweep out in this direction. Our r value is decreasing until it gets to r equals 1. As theta goes from pi over 2 to pi, from pi over 2 to pi, r decreases further until we get to 0. So as we continue sweeping out in this direction, our r value is going to continue decreasing until it gets to 0. As theta goes from pi over 2 to 3 pi over 2, r begins to increase again until it gets back to 1. So as r increases from pi to 3 pi over 2, the r value starts at 0 and is going to steadily increase until it gets out to 1. And then for the end, as we go from 3 pi over 2 to 2 pi, from 3 pi over 2 to 2 pi, r continues to increase until it's back to 2. So we're going to trace out further in this quadrant until r maxes out at 2, or we're back to our starting point. Let's do the same thing for the second equation. So the second is 3 cosine theta. So we're going to have our axis again. Cosine begins at the peak. Our cosine graph is going to dip down, bottom out, and then back to the peak again at 2 pi. This is going to bottom out at pi. And then halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. This maximum height is the amplitude, which in this case is 3. And this bottom y value is negative 3. So let's graph this on the same set of axes. When theta is 0, the r value is 3. So when theta equals 0, our r value is 3. As theta goes from 0 to pi over 2, the r value decreases to 0. So as we go from 0 to pi over 2, the r value will steadily decrease until it gets to 0. I'm going to retrace that out, make it a little bit more circular looking. So at r equals 0. As we go from pi over 2 to pi, theta goes from pi over 2 to pi, the r value is now going to go negative. So as we go from pi over 2 to pi, our r values are negative, which is going to push the graph out in this quadrant until we max out at r equals negative 3. As we go from pi to 3 pi over 2, our r value is going to head from negative 3 back to 0, which is just going to trace out the curve, the top half of the curve a second time. So we really only need to go from 0 to pi for our second curve, the circle. Now, they want to know the area of the region inside, and they're talking about this area in here. Now, this curve is symmetric, so we could look at just the area of, say, the top half and then double that. To do that, though, I see that right here, what the outer function is changes. So in this first section right here, the outer curve is r equals 1 plus cosine theta. Then, for the second half, inside this left-hand piece over here, the outer curve is the blue one, the 3 cosine theta. So we've got to figure out the angle at which the two of them cross. We want to know what is this angle where those two curves cross. So we can do that by setting the two equal to each other, and we see that that's going to happen at theta equals pi over 3. So now, to continue setting up our integral, we know that our area, if we look at just the area of the top piece, this will be 1/2 the integral of r squared from a to b. And then we're going to double this to get the area of the whole thing. However, this top area, the curve that we're integrating breaks into two pieces. So we now have to set this up as two separate integrals. This is 1/2 the integral from theta equals 0, which is where this thing started, up to theta equals whatever this intersection point is, which was pi over 3. And then the curve that we're integrating is the 1 plus cosine theta. So 1 plus cosine theta squared d theta, plus this tiny wedge that's over on the left-hand side, which is the integral from pi over 3, which is where our intersection point was, until the blue curve ended, which was at pi over 2. And then what we're integrating there is the blue curve, which was 3 cosine theta squared d theta. Then we'll multiply this entire thing by 2, and that will give us the total area.